Good morning, everyone. My name is Naixin Li. This is the thesis presentation for ECTE451. Okay, let's start my presentation. My topic is channel estimation and equalization for MIMO OFDM system, and my supervisor is Dr. Lep Changchuan. This is the introduction of my presentation. Beginning, I will briefly talk about the background and the motivation in the MIMO OFDM system. After that, I will explain the channel mode and the three estimators, which are LS, MMSE, and the LMMSE channel estimation. Then I will present the three estimation with simulation and the comparison. Finally, I will show the conclusion. Okay, let's start. In recent years, people mainly use the two kinds of wireless network. One is Wi-Fi and another is the cellular network. The MIMO system is regarded as the key technique of cellular network currently and even in the future. The MIMO system is a wireless communication system that uses multiple antennas on both transmitting and receiving side. It can effectively overcome multiple fading problems. Furthermore, increasing bandwidth and spectrum efficiency to enhance the performance for the wireless communication. Our final purpose in MIMO system is to estimate accurately received signal based on channel state information. However, different noise and fading make the MIMO channel much more unreliable and unpredictable, so the channel estimation process is highly focused in MIMO OFDM system. Let's move to the channel mode. As you see, we assume that there are untransmitting and unreceived antennas. Then the channel is based on mode as this. However, one side of the transmitter and receiver vectors is sufficient to calculate the channel matrix H. So, in order to plot the channel with multiple signals, the system is further modeled as this. The shown the picture below. Transmitter matrix X and receiver matrix Y, and the complex matrix H with additional white Gaussian noise. The procoding technology is in the multiple users MIMO system has been absolute implemented on the transmitting side, especially for linear procoding. It provides a better performance on transmitter with lower complexity. The procoding process, which has been illustrated as the figure below, consists of an encoder and a procoder as transmitter antennas. The encoder receives a bit stream via adding redundancy, and average code bit into vector matrix. Then the procoding of vector matrix is operated in procoder before transmitted. The receiving antenna just operated with a symbol detector. The channel state information is not required for decoding. Okay, let's talk about the OFDM system. There are three main parts I'm going to introduce. Firstly, orthogonality, then the cyclic prefix, and finally the zero padding. The orthogonality is the most essential characteristic of OFDM system. Each subcarrier has been shown as a single bit. After go through the OFDM system, the subcarriers are overlapping with each other, so that the utilization of bandwidth could be enhanced. Inserting the cyclic prefix into each symbol is an essential method for OFDM system. It could animated interblock interference using discrete Fourier transform process. CP use a linear convolution for the received data with repeated information, so the operation could be simplified. The zero padding is an improved technique for channel estimation. The information sample, which have been operated via IFFT modulator, used to add the term of zeros. the length of the AP is longer than CF. Than CP, than CP. So the accuracy of a recovered OFDM system have been proved because of the sufficient intervals. Here the picture of the OFDM subcarrier and orthogonality. Okay, in this section, I'm going to talk about the 3-channel estimation algorithm. There are least square channel estimation, mean square error estimation, and the linear mean square error estimation. Okay, I will present one by one in the following part. First of all, I will present the LS channel estimation. The LS channel estimation has been widely used nowadays. The least square estimation is simple and traditional, used as the channel estimator. It can be present as the equation shown below. But of course, the weakness obviously it suffers from noise and mismatched model seriously, so it has a low performance in noisy channel environment. The mean square error estimation is the method which minimizes the mean square error. Comparison with the LS channel estimation with low signal to noise ratio, the MMSE could be implemented to reduce the influence of the additive noise. In this algorithm, the noise distribution are known, so the MMC estimation could be determined as this function. However, the noise power information is not known, and this algorithm has little improvement. The last one, the least minimum mean square error estimation. It is widely implemented to obtain the optimal mean square error of the channel estimation. It is a special case of MMSE estimation where using this algorithm. Channel estimation could be reduced of computation complexity at the receiving antennas, so the equation could be considered as the following. This one. Okay, before analyzing the simulation section, I want to show you the simulation flows. Initially, we build the relay channel H and generate a signal matrix with additive white Gaussian noise with BPSK. Then we push the transmitted signal into the channel and receive the antenna. We can obtain the received signal stream in matrix. Finally, repeat sufficient times and operating with the channel estimator. According to the simulation flow introduced before, I'm going to talk about the simulation I got for this semester. First of all, the LS channel estimation is shown as a figure. The vertical axis defined as the mean square error, and the horizontal axis denoted as the signal to noise ratio in decibel, respectively. So this curve shows the relationship between the So this curve shows the relationship between MSE and signal to noise ratio. It's clear to find out when the SNR increasing, the value of mean square error will be declined. Okay, then the channel estimation of LMMC shown on the figure below. The vertical axis and the horizontal axis are the same with LS estimation. This figure illustrates the result that the values decrease as the waterfall cave, like this waterfall cave, similar with the LS channel estimation. After analyzing the LS and LMMC respectively, I will show the comparison of these both algorithms for channel estimation. From the observation, the LMM channel estimation could provide a better performance, which the blue light's performance, and better than the LS estimation, the red line. Because the LS transmission does not carry noise into original data stream, hence the LMMSE could be closer to the theoretical values when SNR is increasing. Okay, finally, I'm going to introduce the LS and the LMMC estimation for OFDM system. The OFDM system enhances the performance at the receiver side. Through the BPSK modulator, we could obtain the BPSK data stream. Then the data stream go through the IFT modulator and add the zero padding. That's the most important step. After that, the data stream could be collected from the pilot signal and operating with the OFDM channel estimation. Finally, use a decoder and a demodulator. The receiver signal could be obtained from the receiver, collected from the original signal. From this figure, it is clear to obtain from that the LS estimation is has higher symbol error rate than the LMMSE when the SNR is increasing. However, the value of sample error rate for the both algorithm has been declined with the lower noise to signal to noise ratio. So the LMMSE estimation could provide the better performance than LS estimation because the curve for LMMSE is more clearly for the theoretical values. Conclusion. The MIMO OFDM system has played an essential section in the wireless communication system with a higher transmission efficiency, high data rate, and keeps accuracy and stability of the transmitted signal. It provides a better performance of wireless communication